good morning or good afternoon or good evening, whatever it is, wherever you're watching this video. Okay, I want to give you a video and give you something to study on how to compare forecasts. Here's a spreadsheet that we're going to work with. This is a forecast of an SKU. So there it is right there. Make up your mind whatever that SKU is. This is the actual amount of that SKU that we sold on these days. And if you scroll down, you can see we have 108 days worth of demand information. And we also have data on Don and Sally. They're both forecasters that forecast this SKU during this past period, and we want to compare their performance, see how they did, see how they differ. In this column, this is Don's forecast, and in this column we have Sally's forecast. And in this column, I'm going to delete it, and we'll start over. Okay. So what we want to do is we want to calculate the forecasting performance measures that are in the book, right? There's a forecasting measure called the forecast error, which is really just equal to the actual minus the forecast. There's something called the mean absolute deviation, which is equal to the absolute value of the forecast error. The average, okay. There's the mean square error. There's the mean average percentage error. All of those things we're going to calculate. I'll just copy them over here for now. Get them out of the way. Okay, so let's work with Don first. Here's some columns for Don's performance. And right here in this first column, I'm going to calculate the forecast error. Go down to the first cell. I'm going to use the plus sign to start my equation, and I'm going to click the actual column, and I'm going to subtract the forecast. And that's a 0. That means he forecasted perfectly. And then I'm going to copy that formula all the way down for all 108 days. And I can do that several ways. One, I can grab this little square in the lower right of the box and drag it down a few. Or I can right click on a cell and hit copy and then go to where I want it, maybe these two blanks, and hit paste. Start over. Copy, paste, easy enough. Or the easy way is to double click on this square in the bottom right of the cell and it takes it all the way down. Okay. So we've calculated the forecast error for every day for Don. And next we want to calculate the running sum of forecast error, which is just what it sounds like. We take the first day and we add the forecast error of the second day and add the forecast error of the third day, etc. So the running sum is the sum of this entire column. Okay, so I type at sum, open parentheses. I'm going to left click on the bottom and drag it all the way to the top and close the parentheses and then press enter, and that completes my sum right there. Okay. Couple of things I can determine from this right here. One, I know that for this 108-day period and this SKU, Don has over forecast. And I know that because this number is negative. He's overcast by 372. I really don't know if that's good or bad. If I've sold 20,000 of these things and I over forecasted by 372, that's probably pretty good, right? But if I've only sold 50 and over forecast by 372, that could be really bad, right? You got to have something to compare it to. And if you haven't noticed, that's kind of a theme of evaluating a lot of these metrics in logistics that we're looking at. We have to have something to compare things to. In this example, we're comparing Don's performance and Sally's performance. There are lots of other examples of comparing forecasts that you will come across or do. Maybe you want to compare not Don and Sally's performance on one SKU, but maybe you want to compare Don's performance on two different SKUs. Or maybe you want to compare Don's performance this year versus last year. Or maybe you want to compare your company's performance with your competitor's performance. Or maybe how your company did this year compared to last year. You've always got to have something to compare it to in order to decide how you're doing. Okay? So this example, again, we're going to be comparing Don and Sally. But right now, we're just trying to get all of the numbers for Don. Okay, we've got the forecast error. We have the sum of the forecast error. The next thing we're going to work on calculating is the MAD, or the mean absolute deviation. So in this cell, I'm going to hit an @ ABS, which is absolute value. I'm going to open the parentheses, and I'm going to click on the forecast error, close parentheses, press enter. This blank now has the mean absolute deviation. Double click and copy it all the way down. I'm going to go to the bottom, type mean absolute deviation, go to this column, I'm going to hit @sum, open parentheses. This time I'm going to show you a different way to highlight. I'm going to just click on the lower box. I'm going to hold down Control Shift, and I'm going to hit the up arrow, go all the way to the top, and then I'm just going to grab the top of my shaded area and take it down to cover just the numbers. Okay, once I do that, I'll close the parentheses and press enter. This is the sum, but to get the average, I need to divide it by the 108 rows of data that I've got. So my mean absolute deviation is 18.2 essentially. Okay, next. Well, first a little bit about the absolute deviation. Why did we do that? Okay. If we're just looking at the forecast error, it can hide some of the problem, right? So some months Don under forecast, some months Don over forecast, and when you average them together, it looks like he's doing really well, right? You've probably heard the joke about two logisticians and a statistician going target practicing, right? Logistician 1 fires at the target and it lands 1 foot to the left. And logistician 2 fires and the shot lands 1 foot to the right, and the statistician says bullseye, right? So that's the same problem you've got going on here. You've got under forecast, over forecast, and when it's averaged together, it washes out how poorly you might have done. Okay? When you take the absolute value of the forecast error, you're capturing the total error, right? So you're adding together all of the times that you under forecasted, and then when you over forecasted, you're changing the sign of it and you're adding it to all the other times. So this is a total forecast error essentially. Okay, and at the bottom, this is the average forecast error. Okay, so on the average day, I am off by 18. Okay, I'm really over forecast by an average of 18. Okay, we're going to calculate another column. This one's called the mean square error. In this one, I'm going to again start with a plus sign, and I'm going to go over and highlight my forecast error. This time I'm going to hit Shift and 6, which is the up caret, and hit 2. That is the way that you square a field in Excel. Then I press enter. Here I can copy it down by dragging, or I can double click that box. Goes all the way down. Okay, so now I've got the item squared. I'm gonna hit the mean square error. I'm gonna come over here. I'm gonna hit @sum, open parentheses, drag to the top, close parentheses, press enter. There's my mean square error total. I'm going to divide that by 108 to get the actual mean, and it's 843. The mean square error, what that does is that penalizes really bad forecasts. Okay, so if we just kind of look at some of the data, here's one where we're off by just a little bit. I'm off by just 2, and the mean square is just 4. Okay, so that's a minor penalty. But here, let's say this one I'm off by 75, and if I square that, look at the size of the penalty that's given to that day. Okay, here's another one. I'm off by 38 here, big penalty. Here I'm off by 1, very small penalty. Okay, so this mean square error column, this penalizes variability. Okay, that's key. It penalizes variability, which means if Don is very tight in his forecast, he's always over by 1 or 2 or 3, then he's going to get a pretty good score there, right? If every now and then he just blows it out of the park and he's off by a huge amount, then it'll be penalized and it'll show up in this mean square error. Okay. Next, I'm going to calculate the mean average percentage error. I'm going to start with a plus sign. I'm going to open parentheses because first I'm going to get the forecast error divided by the actual. Close parentheses, and then I'm going to divide it by the actual. Is that right? Well, let me start over. I want the forecast error divided by just the actual. Let's just start with that. Okay. And double click all the way down. Okay, so this is the relative measure, meaning I can compare this with other forecasts more easily because it's put in percentage terms. So mean average percentage error. If I come over here, I'm going to add sum all of this, which is my percent deviation. I'm going to divide it by 108. But then I'm going to multiply it by 100 to put it in percentage terms, okay? So this would be a percent, which means so he over forecast by 125% on average is how you would read that, okay? That's a number that would be easy to use to compare how Don did on different SKUs that have different average demands, or how Sally, we'll use that to compare against Sally. Okay. So that's Don's performance, but again, looking at these numbers, we don't know if he's done well or not. He hasn't done perfectly because he has some forecast error, but until we know, what we're comparing it to, this might be worse than last year, which means it's bad. This might be better than Sally, which means it's good, right? It's all relative. Major theme of this class, right? Okay, so let's do Sally. And we can do Sally a little easier because we can copy. Before we copy it, I'm going to change a couple of things in the data. So when I copy this cell, if I copy this cell over to here, it's going to increment these letters, okay? And I don't want this column C to change because the actual is used for both calculating Don's and Sally's. Okay, so in this forecast error, I'm going to put a $sign in front of the C, and I need to copy that formula all the way down. Okay, just check a few of them. See, I got $signs in there now, and the numbers didn't change. D. Okay, so I'm going to go over here. That looks good, and that looks good. This has a C in it. I'm going to again anchor the C by putting a $sign and copying it down. Okay, next I'm going to highlight all this information, and I can even highlight the numbers at the bottom. Right click, copy, paste it right there. Now let's look at it. Okay, does this look right? Not quite. Got the C correct, but it's subtracting the H column. So let me change this H column to the E column, which is what I want. Double click all the way down. Does this look right? This is absolute value of J. Yes. This is the up caret of J, that's correct. This is J divided by C, that looks correct all the way down. Okay, so now we can compare. These would be Don's numbers, these would be Sally's numbers. Let's just look at one at a time. Here, first of all, running sum of forecast error. Both of our forecasters tend to over forecast because this number is negative. Sally, by looking at this number, Sally over forecasts by a larger amount. Looking at the mean absolute deviation, first of all, ask yourself, do you want this to be high or do you want this to be low? You're going to want this to be low. This is the, remember, the absolute deviation of the forecast error helps you measure the total forecast error amount, and it's not washed out between what's negative and what's positive. So you want this number to be as low as possible. By looking at this, Sally does a better job of the forecast, and this is a more reliable measure than this running sum of forecast error. Okay, so Sally's got a better MAD, she's doing a better job. Let's look at the mean square error, and this might explain why Sally's MAD is better, because since the MSE is higher for Don, that means he is being penalized in this measure for some of that variability that he has. Okay, so in the net bottom line of this is Sally is a more consistent forecaster. Her variability is less. Okay. Over time, if I'm just comparing the two here relatively, the mean absolute percentage error is lower on average for Don. Okay, so Don is going to have a better measure there in that number. Okay. Okay, so again, I'm comparing Don and Sally. You can compare lots of things with these same measures. You're always comparing forecasts, but you can compare how Don did this year versus last year. You can compare how Sally did on SKU A versus how Sally did on SKU B. You can compare how Company A did against Company B. You can compare how Company B did in Georgia versus how Company B did in Florida. Compare anything. You got two forecasts, compare them. But now that you know what these measures are a little bit more, you can become much more, you can talk much more intelligently about this, right? You're going to see these numbers again. These measures are used commonly. And if you guys know how to interpret them and you're sitting around the conference table in a couple of years, you're going to look really good, right? People are going to struggle. They're going to look at this. Usually a company will focus in on one particular type of measure that they like and they're comfortable with. But if you can color that with an analysis by using some of these other measures that they don't use, then you're going to increase your value at the company, and that's what we want. Okay. Thank you, and I will talk with you later.